Hello and welcome to the Cyber One YouTube channel. So last night while printing out parts for Fred, I had a problem occur with the 3D printer. So what we're seeing here is the temperature graph produced by Octoprint running on the Raspberry Pi. The blue line here is the bed temperature, and you can see here I've got some small dips prior to a larger dip here, and then the printer going into fault. Now the fault that was reported is thermal protection because the temperature drifted too far on the heat bed. Now there's two ways you can get this type of fault. One is when a thermistor fails due to a broken wire. Normally you see that as large spikes down to zero and back very quickly. The small ones, like we're seeing on this one, are very indicative of a broken wire to the heater bed. So we're going to pull the printer apart and see if we can find what actually went wrong. I suspect broken wires on the heater bed, which I've had before, not all that long ago, but I didn't have the correct wire to put in. So I'm going to pull it apart and put in the correct wire this time. I'll be using a flexible wire, 2.5mm cross-sectional area, which has got more than enough capacity for the job. So let's change our view and have a look at the printer. Okay, so mid-print, I've still got the print sitting on the bed. Now that it's cooled down, this just falls off. So I'm going to raise the Z-axis up to give us more room. This did do a reboot after the error occurred. The Raspberry Pi has already lost power for some reason, so we'll unplug that and turn off the printer. So I've made modifications to this with the front. These leg stands at the front and the back bracing. So I'm going to have to remove all of that in order to get this bottom piece off. Okay, so our wires going to the bed are these ones. The thin white wires are the thermistor, so we'll unplug those. And in this case it's a black and red wire going to the hotbed terminals. Now there's a cable tie on the back here that holds the cable in place. So we'll cut that. And now we can pull the cable out. There are 4 thumb screws that hold the bed on the carriage. These are my modified units. I 3D printed these with a nylock nut in it, and the graduations on it give me 0.1 adjustments. Very handy when you're leveling the bed. Don't lose the springs as you lift the bed up. There's 4 of them, 1 on each corner. So the thermistor is usually just held on with a bit of tape. I've got a cork underlay. The cork underlay, in this case, holds in my thermistor as well. Here's where my brake is. And there's another one just there. So both my wires are broken. Alright, let's move to the desk. Okay, so the biggest problem we're going to have with replacing these wires are these two solder joints. Now, soldering is normally not an issue, but in the case of this is a heated bed with an aluminium plate. So the PCB heater is actually fused onto this aluminium plate, and this aluminium plate's very good at dispersing heat and distributing it evenly, which is a problem when you're trying to get heat to a pinpoint location. Now, the reason these wires failed, and it hasn't been all that long, it's only a month or two since I replaced these wires. The reason they failed is because the wires have not got that many strands in them. That means they're not very suited for continual flexing. So let's cut that strip a little bit and I can show you what I mean. It has got more strands than I thought it had, and it's all copper, but they've obviously been folding in the same spot. I think that's a 1.5mm diameter or cross-sectional area. Now these are the new wires I'm going to use, and these are 2.5 cross-sectional area. Now the 1.5 will carry the current without any trouble at all, but the 2.5, and this one's got lots of strands in it as well, mechanically it's going to be stronger. So what I might do is get something to apply a lot more heat than I had before when I did these last time, and we will try and desolder those joints. Now I do have a good soldering station here, but with the heated, or with the aluminium plate, I just cannot get it to get up hot enough to melt the solder. So what we're going to do is prepare our wires first. Okay, so that's up to temperature. Now this process, for those who have never really soldered, is known as tinning, and basically we're just getting solder into the wire and that'll help with doing the joint up. Now these 2.5mm wires are fairly heavy, so I am putting a fair bit of solder into it, mostly because it is so heavy, and it fills in all the gaps between the strands, and it's going to make it easier to connect this. Okay, so in the past when I did these joints, I attacked this in multiple ways. I used a soldering iron with a much bigger tip than the one I'm using at the moment. I also applied the rework station hot air at the same time, just to try and get heat into it, and I just couldn't heat it up fast enough. So this time I'm going for the blowtorch. And I'm going to try not to burn myself at the same time. And I've managed to tangle up all my wires. That's my first one. And that's both my wires soldered on. Now normally I don't like using something as hot as that when soldering with just ordinary solder, but in this case there's just no other way to get the heat into the board fast enough. I did scorch my insulation on the positive wire a little bit. Now this wrap actually came with the printer, and it seems to do a reasonable job, so I'll keep using it. The main thing you want with the wraps go around them is you don't want them to be able to get caught on stuff. You need it to be able to slide over the framework very easily, otherwise it can create artifacts inside your print, and that's something we really don't want. The process for replacing the thermistor, and yes they do fail, usually the wires, is very similar to this, except you don't have to worry about the difficult solder joints. You just literally pull the thermistor out of this, put the new thermistor into it, and then reassemble it. Now the wires I've got are far too long, so I will trim them to suit. So we've got two holes, one at the front, one at the back. I'm just checking to make sure these screws aren't showing any signs of being loose. While I've got it apart, I might as well. That one was loose. That one was very loose. So was that one. Okay, so the wires go to the back. Don't forget to put the springs back on. Next I need a cable tie. And there's our bed terminals there. Now they used to have a surround on them like the others, but the replacement thermistor I got in, and I have a heap of them, won't fit into those surrounds, so I removed it to have just the pins, and that makes it a bit easier. Now when you're putting these in, check and make sure you've got all the strands in. If any of the strands are stray, they can short together, and that's not going to do your motherboard any good, or your main board. The terminals need to be tight, but don't go overboard. If you over tighten them, you can actually twist twist them and do some damage to the board at the same time. Okay, time to put it all back together. Oh, there it is. Right in the middle at the back. Now I can plug it back in. Turn it on. Now if you don't have a BL Touch installed on your printer, I do highly recommend getting one. They do make life so much easier. So on the display here we've got minus 0.53 in the back corner. The front right it is positive 0.42. The back right is positive 0.43 and the front left is minus 0.97 with the middle being 0. So that tells us that the bed's running a little bit high on this side and a little bit low on this side. In this case I think we will actually crank this side down. So that's a full turn on these screws. In the front and the back, this side is a full turn lower, or almost a full turn lower than the back. So what we'll do is we'll actually come up and just rerun the test and see how that affects our leveling. Now of course the other way of doing it is the way they tell you originally in the manual before the BL Touch is installed, and that's to get your bit of paper and or your feeler gauge and level each corner one by one. This is, you know, a lot easier. And that didn't make a lot of difference. It got closer, not as much as I would have liked. So we're back left minus 0.02, back right minus 0.15, front left minus 0.24, front right minus 0.03. Now that's well within range for the auto leveling to work. That could be tweaked further. It's showing me a little bit of a warp in it. But other than that, that's pretty close. The back left and the front right were almost spot on for us. Now with a small printer like this one, it's easy enough to adjust the leveling screws on the big printer to the left of it. It is a lot harder to get to those leveling screws, and using the BL Touch is so much easier. Minus 0.2 on the front left and minus 0.16 on the back right. The back left is minus 0.02 and the front right is minus 0.01. The middle points, so the dead center is 0.00, the middle back is 0.00. the middle left is minus 0.05 and the middle right is minus 0.08. So we're pretty close. We could potentially adjust these a little bit more. In this case, I'm lifting them up just by 0.1 of a mil in each case. But every time you adjust one of your screws, rerun your leveling routine, and it'll tell you just how much closer you are. It pays to, depending on how much you're printing, run the auto bed level and just try and tweak your level in closer to level. It means a BL Touch and new auto bed leveling routines don't have to work as hard during the print, and you'll get a more accurate print. So in this case, our back left is at 0.00, our front right is 0.02. We've only gained 0.02 in height on the front left, so 0.18 negative and 0.19 negative on the back. We're not really getting much of a change at all as we adjust it. So I think I might just call it at that. It seems to be warped the bed slightly down. That could be because I put concentrated heat in the middle at the front, sorry, at the back. That may have created some warping, and it may flatten out when I heat the bed. And that brings us to the next test that we should really do, and that is to preheat the bed. So I'm going to take the bed up to 50 and take the nozzle up to 180. The bed temperature is rising. It started out at 20, it's already up to 23. The head's the temperature. And now the bed is up to temperature and is holding at temperature. So that seems to be working. Alright, so that'll do for this video. Back into operation. I've got the Raspberry Pi starting back up, and I'll be able to continue printing. If you like these videos, please click on the like to see when more videos come out. Don't forget to click on subscribe and ring that bell, and we will see you in the next video.